Greeting my peoples. Welcome to my channel once again. Hope you are having a good time over there. In today's presentation, we are going to be looking at the part 2 of naming an organic compound. In my previous presentation, we discussed about the part 1 of naming an organic compound. You can check the video for yourself. It's one of the videos I have in my channels. I will already paste a link to the video on the comment section after this presentation. So in today's class, we are going to be looking at the part 2 of the detailed process of naming an organic compound. So sit back, my dear friends. Let's enjoy the class together. In naming an organic compound, there are certain factors to take into consideration. A named organic compound is a product of 3 factors. The first is the number of carbon atoms present in the compound, which gives the parent name. The number of carbon atoms present in the organic compound, which gives the parent name. In this case, since we have 6 carbon atoms, the 6 carbon atoms here is hex, which is hexane. Then let's look at the number 2 factor. The second consideration is to detect the functional group present in the organic compound. The functional group takes the suffix name to detect the functional group present in the organic compound. And when we detect this functional group, the name of that functional group now takes the suffix name. We can see an example of functional group in the structure we have above. We have a structure of a propanol. A propanol is an alkanol. It's from the alkanol family. You can see that the OH in the propanol is shaded or circled. That is to tell you that the OH is the functional group. So in this compound, we have to first of all identify the functional group. After identifying the longest carbon chain, the second assignment we have is to indicate the functional group. So if you look at this compound, you can see that we have 3 carbon chains. They are in the longest carbon chain here. We have 3, and from the naming of an organic compound, 3 is the group. And taking the suffix of an alkanol, it takes the all suffix. That's why we have the propanol. Let's look at another example of a functional group. That's the carboxylic functional group. We have the carboxylic functional group as the COOH. So any compound that this COOH is attached to takes the name or adopts the name. Let's take that hexane as an example. That's 6 carbon. We can have them as hexanoic acid. Then we have the carbon to carbon double bond. That is for alkenes. The carbon to carbon double bond. This one is for alkenes. That's the double bond is for alkane family. Then the third consideration is the identification of any attachment to the parent carbon chain and identifying its position. Identification of any attachment to the parent carbon chain and identifying its position. This structure shows the shaded 6 carbon atoms as the parent chain. You can see the 6 carbon atoms that is shaded, and they are numbered as well. That is the parent chain. The parent chain is numbered to give us the position of the attachment present. Remember, an attachment is any compound or element outside the parent chain. In this case, our attachment here is the CH3. We have the 2 CH3s that are being circled. These 2 CH3 are our attachments. Now, from the numbering, we can see that the attachment, which is CH3, are both on carbon number 3. Having considered these 3 rules, we can now name this compound as 3,3-dimethyl hexane. 3,3 because the 2 CH3 are on carbon number 3. This CH3 is called methyl, And since it's 2 in number, it becomes 3,3-dimethylhexane. Hexane is because we have the longest carbon chain here to be carbon number, the longest carbon to be 3. That's why you have it as hexane. The longest carbon atom here is 6, sorry. We have the carbons to be 6 in numbers. Because they are 6 in numbers, it takes the name hexane. Now, for an in-depth understanding of the process of naming an organic compound, there are rules which you are going to consider. For you to name an organic compound effectively, you have to follow some rules in naming these organic compounds. Well, I'll present the rules here and explain it to you one after the other. The first in the rules is, first, identify the longest carbon chain in the compound. Identify the longest carbon chain in the compound. If you look at the structure we have there, the arrow in this structure shows the direction of the longest carbon chain. So if you are counting following the arrows, you will see that that direction of the arrow will give us the longest carbon chain. So because that direction gives us the longest carbon chain, we adopt the number of the carbon chain as to become our parent name for this compound. Then secondly, we identify all the substitutes present. We identify all the substitutes present. Looking at this structure as an example, you will see that the substitute here is the CH3. Look at the parent chain. If you look at the parent chain as written, is indicated there, parent chain. You will see that anything, like we said, that attachments are anything outside the parent chain. So we can see that we can have some CH3 outside the parent chain. These CH3s we have outside the parent chain is what we call substitute. Now, for us to now name an organic compound, after identifying the parent chain, we have to identify as well the functional group present so that we can know the family or compound that is we are about to name. Then finally, we check the substitute. So in this case, we have 3 substitutes, and the 3 substitutes are all CH3. You can see for yourself in this structure, the marked parent chain is straight, and the substitutes are all outside the parent chain. And because they are all outside the parent chain, we consider them as a substitute. So we've identified the longest carbon chain. We've known how to do that. We've identified the substitute. Then the third one is to number the carbon the carbon parent chain from the end that gives the substitute the lowest number. The third rule is to number the carbon parent chain from the end that gives the substitute the lowest number. You can see for yourself in the structure marked with green good is the current way of numbering to give the substitute the lowest number. If you look at the structures very well, you'll see that the structure on the left, the numbering starts from the left, so that we can have the CH3 attached on carbon number 2. Then if you look at the one in the right, the diagram, the structure there, you see that the numbering starts from the right, giving the CH3 the 4th position. But for us to obey this rule, the rule says that we have to number from the end that gives the substitute the lowest number. So for us to obey this rule, then we have to adopt the structure on the left. So that the one that gives the CH3 the 2nd position. Then we have the 4th rule, which says that if the same substitute occurs more than once, the position of each substitute is given. If the same substitute occurs more than once, the position of each substitute is given. Let's take this structure for an example. This structure gives us 3 substitutes which are all CH3. they gave us the structure gives us 3 substitutes, which are all CH3. Now we have to identify the positions of this substitute. Then, following the numbering rule, we can name this compound as 2,5,5-trimethylheptane. 2,5,5-trimethylheptane. 2 because if we are following the numbering rule, you can see the carbons are numbered. Following the numbering rule, you see that given the CH, which is the first attachment, the lowest possible number, we have to start numbering from the left so that the first CH will take the position number 2. Then if the first CH takes the position number 2, the second and third CH are on the carbon number 5. And because they are on the carbon number 5, and the rule says that we have to name and indicate the position of each of the substitute. Already we have 3 substitutes. Now for us to tell them that we have, or whoever that is that hears the name that this compound has 3 substitutes, we have to tell the person that the first substitute is on number 2, the second and the third substitute is on number 3, and the 3 substitutes are all methyl. That is why we have them as 2,5,5-trimethylheptane. The 5th rule says if there are 2 or more different substitutes, they are listed in alphabetical order. If there are 2 or more different substitutes, they are listed in alphabetical order. Looking at this structure, you can see that we have the Bl, that is bromine, we have the Cl, that is the chlorine, and we have the CH3, that is the methyl. They are all substitutes. They are all substitutes because they are all an attachment on the parent carbon. The Cl is on the same line with the parent carbon, but because it is not a carbon atom, it is not considered as part of the parent chain. So, for us to name this compound, we have to follow the alphabetical naming, which is given B. If we follow the alphabetical method of naming, bromine, which is B comes first. Before B comes before C in the placing in alphabetical order, and C comes before M. The B is for bromine, the C is for chlorine, and the M is for methyl. So if B comes before C, we have to name B first, that is bromine, before C, and if C comes before M, we have to name C before the M, which is methyl. So in naming this compound, after proper numbering of the carbon parent chain, we have the name as 4-bromo, 1-chloro, 4-methylpentane. 4-bromo, 1-chloro, 4-methylpentane. So the numbering is, you don't consider the attachments, that is the alphabetical order of attachment before numbering. You can see that the first numbering here is from the carbon that is attached to chlorine. That is the one that gives that functional group the lowest possible number. Now, after proper numbering, then in naming, you now consider the alphabet. That is B for bromine, which comes before C for chlorine, and which comes before M for methyl. Then we also have the 6th rule, which says that the prefix cyclo is given to a cyclic or ring hydrocarbon. The prefix cyclo is given to a cyclic or ring hydrocarbon. Let's look at those structures as an example. Cyclic or ring hydrocarbons, as these structures, they are where the carbon, cyclic or ring hydrocarbons, as seen in this structure, we can see that the carbons are bonded to each other in a cyclic form. In this structure, the first one has 3 carbons and is named as cyclopropane. You can see that the 3 carbons are bonded to each other, forming a ring. And because they have formed a ring, we call them cyclopropane. The second structure has 6 carbons and is named as cyclohexene. If you look at the 6 carbons, you will see that all of the 6 carbons are attached, they are bonded to each other. And because they are bonded to each other, they form a ring. And this ring, because they form a ring, they belong to a group of hydrocarbons which we call the cyclohexane. Now, hexane, because we have 6 carbon atoms, and in the first one, propane, because we have the 3 carbon atoms. So the only difference here is that we add cyclo to indicate that the compound is in a ring form. For compounds with functional group other than carbon-to-carbon single bond, as those ones we explained, we give numbering preference to the end that we give the functional group the lowest number. Let's take alkane and alkene. The double bond in alkene and the triple bond in alkynes are given the lowest number when numbering the carbon parent chain. The suffix is "-ine" for alkene and "-ine" for alkyne. For an example, in the structures we have here, you can see that the alkene is an alkene because it has carbon-to-carbon double bond. So that carbon-to-carbon double bond makes it automatically to belong to the alkene family. Now, looking at the compound and the naming, you can see that it is named to give the functional group, which is the double bond, the lowest possible number. Look at the first one. We have the first one as 2-pentene. 2-pentene. That 2 is to tell you that the double bond is on the carbon number 2. That is why you have it there as 2-pentene. The "-ine", which is also in the pink color, is to tell you that the functional group here is a double bond. That is the "-ine". It belongs to the "-ine" family. Then look at the second structure there. It is still an alkene group. Now we number, given the alkene, the lowest possible number. If you look at the compound, you see that we have 6 compounds here. They are both, the alkene is in the middle. So because the alkene is in the middle and it has an attachment, we have to also consider the attachment. So if we consider attachment, we'll see that we will now have 2-methyl, that is, the attachment is on the carbon number 2, 3-hexene. The 3 is to tell that the double bond, which is the functional group, is on the carbon number 3. Then if you look at the other structure, the structure on the right, you will now see the numbering pattern. The carbon-to-carbon triple bond is also given the lowest possible number, which makes it to be on the position number 3. So in naming of this compound, we have them as 7-methyl 3-octane. Octane, the "-ine" there is to tell you that the compound is carbon-to-carbon triple bond. Let's look at alcohols. In alcohols, for instance, in alcohols, you number from the end that we give the functional group OH the lowest number. You number from the end that we give the functional group. The functional group for alcohol or alkanes is OH. So you number from the end that will give the OH the lowest number. The ending suffix for this group, that is for alcohols, is all, OL, all. That is whatever compound we have, after naming the number of carbon atoms, we end it with all. The example are shown in these structures. You can see that in all the structures, the numbering gives all the lowest number. The first one is the 1-butanol, telling that the OH group is attached to carbon number 1 in the parent chain. Then if you look at the second structure there, you also see that the 2-butanol is telling us that the OH group, which is the functional group, is attached to the carbon number 2. And if you look at the numbering pattern, you will see that the OH group is always given the lowest number in numbering. For alkanoic acid, or you can call it the carboxylic group, count from the carbon that carries the OOH and give it the suffix name oic acid. Take a look at these structures and numbering. If you look at these structures we have here and their numbering, the number 1 carbon is the one that carries the OOH. That if you look at the first structure, the number 1 carbon is the one that carries the OOH. The first structure has only 2 carbons and is named ethanoic acid. The second one has 4 carbons, and if you look at the 4 carbons, you will see that the carbon number 1 is on the one that carries the COOH, the one that carries the OOH. That is where the carbon that carries OOH assumes the number 1 position of the carbon. And because we have 4 carbon atoms here, it is named butanoic acid. My people, this is how an organic compound is being named. The alkane, alkanes, and the alkanoic functional groups is to act as a guide for naming other functional groups. I want to believe you can now comfortably name an organic compound after watching this presentation. If you like the presentation, show some love by subscribing to my channels and hitting the notification bar to get notified of all my videos as soon as I release them. Thank you and God bless you. Have a nice day over there.